Thank you so much, everyone, for joining us for our panel today on model improvement. Today, we have some excellent panelists, John Trenkle and Christopher Brown. So I'm going to go ahead and kick off an introduction, and then we'll dive into this talk itself. So John, say hello, give a little intro about what it is you do.
Okay, I'm John Trenkle, and I'm currently at Tubi TV, where we're simply put, we're a Netflix competitor, but we're in the AVOD space, meaning we're advertising based. But in the past, I've for many years done advertising and ad tech at TubeMogul, which is where I met you, of course. And prior to that, I've done 25 or 30 years of defense contracting and working with everybody from NSA, FBI, CIA, NASA, doing things like some of the original OCR for the Postal Service, Arabic recognition for NSA, drug discovery for Eli Lilly, lots of different things, but the common denominator is that all under the hood is related to machine learning. That's the nugget I take away.
There's so much to dig into what you just introduced. Chris, the next, I'm going to introduce Chris next. Chris is the only person who hasn't used the fireside background, but it's because he has an actual fire behind him. So
actual fire right there.
Chris, go ahead. Say hello to folks listening.
Yeah, hello everyone. Thanks for joining. I'm Chris Brown. I am currently the Chief Data Science at ADARA. We are a data and travel company. We serve the travel space and financial services through identity verification products, our marketing products, etc. I've been there for just over a year now. Prior to that, I taught machine learning at UC Berkeley, Yay Go Bears, and also ran my own private consulting company for about a decade. I came up through the stats ranks before they called this thing data science, and I've been doing machine learning for over 2 decades.
It's amazing. I'm excited for what you both are going to share today. So, I want to kick off kind of the first question, maybe to you, John. You've put a lot of models into production, a lot of different organizations. How do you decide, when that V1 of a model's going to go into production? When do you decide it's ready to hit the real world?
Right. Well, yeah, there's obviously a lot that goes into that. And of course, with the presumption that you've actually made a model that's useful for the product you're doing, number one, of course, first principles, to me, relative to saying, when is this model ready to go? It would be first and foremost, of course, is the data that you've used to try to do that model available in platform, right? Number one thing, is it available? And speaking to your expertise, is that data going to be reliable, have high integrity, measurable, all the good things? Because the last thing you want is to have data that's not stationary going into a model. We had this experience in TubeMogul, I don't know if you remember, but that's not what you want to have happen relative to this being out there. So you want to make sure your data is solid. And then, obviously we're big experimentalists, and I'm of the mind of get it in there faster. And if it doesn't work, so long as you believe that it's not going to break the system, you want to get in there as an MVP as soon as possible. But it all still stems to all that offline work you do. So you have your model, you've certainly defined offline tests that you believe speak to online. It's not always true, and it has to be a lot of care taken to do that properly, to say that those statistics you have offline speak to the system itself. But then, of course, all the great things you need to have, the unit testing, the testing on regression, the testing of everything that speaks to it being pretty much ready. And then, of course, before deployment, always, and we have a big system set up for this, is the experiments you'd run to say that, in fact, in platform, doesn't break stuff, looks pretty good, and put it out there. But typically speaking, if it's a first run model that hadn't been done before, like for example, our system, we had recommendation, we went from one day, no recommendation to recommendation, huge. And what you want to make sure is it doesn't break the existing things going on, thus all the testing. But once you get that great ramp up, then you're that great situation where you have an end-to-end that works, and refining end-to-end systems is awesome, because now you have data that speaks to where you were performing, and you can now do those incremental improvements and so forth. But long story short is it just has to check off some boxes relative to being able to go and not break things and work. And if it doesn't work, you discard it and move on. But it's all about lots of models, move fast, adapt to what you're doing. And no one ever expects a model in this industry to last more than a couple months if you're lucky. So you're going to keep looking at the next target and what happens, because there's nothing stationary. One last thing for our world, the catalog grows, the user base grows, everything changes. So nothing can be presumed to last over time. So you're always going forward and moving and putting it out there.
So John, I have a couple questions because you bring up a number of points. But the first one, you know, I'd like your take on is one of the things that I think is really important about putting something into production is having a clear notion of how you're going to make that model better in the future. Because one of the things that happens when you know, rubber meets the road is you're never releasing the model that you think is the best. You're always under some time constraint, right? And you're like trying to release a model, but it's never quite the best. Right. One of the things that I try and instill in my teams is like, look, we have to, and I think most machine learning engineers know this, is we have to know how to measure the model, right? And measure it. But the other thing that I think is less common, and this is where I'd like your opinion, is like going into production with knowing how you're going to improve the model, like already having that plan in place for V.2. Like, is that something that you also instill in your teams? And you do a formal process around that?
Yeah, you know, that's a great thought. And so I would say that our team over here, which is, you know, now numbering in the dozens now, is just because of the way we do things, it typically is, we already have this grand number of ideas that we want to do, and the delivery is always way, way less than you wanted to do. So in fact, we typically do have more of a modeling where we've done the brainstorm and we figured things out and we say, what if we do this? I mean, the sky's the limit. What if we do this, this, and this? And we have that great notion of where we could be. But then you back off and you say to yourself, you know, I really have to take first principles and do this more simply and incrementally. And therefore, we typically have lots we want to do and therefore have that plan of how we can improve it. But it really does boil down to distilling it to the essence that we believe is going to be fieldable, but also going to yield the outcomes we want to see, and then testable. And then the beauty is we have a roadmap already sort of fulfilled that says, oh, if we did, then do this next, whether it be, and I'd say structuring things so that you can additively do things, depending on the model. For example, can you easily fold in more features from the space that you think now could be beneficial? Can you, when it boils down to algorithmic changes, you know, there's a different take there where you'd probably bifurcate and have a different model per se. You know, what you would call incremental changes on the existing model to me is in the parameter space or the data space. But if you have to take a new algorithm, that sort of draws the line between a differentiation between an original model and an entirely different model, which is a new version possibly, or could be something where it's just a whole new take. But that's kind of where it is, where am I going to do parameter optimization or feature engineering, or am I going to wholly take another approach, for example, move away from XGBoost to say something in TensorFlow relative to being neural net based. And that's a great disjunct. So you got to be very careful there.
Careful,
But I do like incremental. We do always have a path for what we can do next, how we can do that. And there's many different dimensions on how we can fulfill that. And I'm speaking, of course, to our world in this case of recommendation and all the takes we can bring to bear relative to typically new information on a user and recharacterizing them more, new information on titles. And there's a great interplay, but we do usually have that grand notion of where we could be. So typically I'd say we deploy something and we could probably be, if we wanted to, polishing that apple for quite a while trying to pursue something else.
Are there clear defined metrics? I mean, Chris?
Well, certainly, depending on your industry, there's a specific KPIs you agree upon. And typically, you know, I'm of the mind of one KPI would be ideal. Sometimes you need two just because there's different enough. So in our world, it's viewing time. Obviously, you get the users to view more. And then retention, keeping them around. But because we're in advertising, of course, this typically figures around to, if you can measure it, of course, revenue, which you'd like to think is correlated with TVT, and somewhat it is, but there are very different takes you can have to wrestle with getting more viewership. That doesn't necessarily mean that you're getting more revenue, and revenue is a track unto itself. But so we typically have three, but you want to kind of have as few KPIs as possible. Otherwise, you're just scattershot optimizing one over the other, and you don't know the trade-offs.
Yeah, I mean, the one that you're always looking for is, can I tie this to dollar value, right?
Exactly.
That's the holy grail, right? Is
yeah.
What is the benefit that this will do driving to the business or the product or the application? That's the one you're always trying to get to. And oftentimes you're falling short in optimizing for something that is that you assume is fairly close to it, or people agree that is fairly close to it.
I agree. Now, this is my turnaround to you, and an interesting question because of the space you work in. How much have you seen people actually putting the plumbing together to start connecting those dots and actually go from what is fielded out there to, in fact, seeing point of purchase and tracking? Because that's, like I said, the holy grail. And I'm wondering to what extent your industry has actually fulfilled that.
Because we deal with a lot of different players in the industry, because we're provide, services to, hundreds of different people.
Right.
It varies quite a lot.
Yeah.
Some people are very sophisticated and are very talented at like tracking and quantifying their return on advertising spend. And others are, are just, taking shots in the dark. And you sometimes wonder if they know what that means, right? What the ROI is. Generally, we try and push them, as a process, we try and push them into those directions of like, hey, you need to be performant until what you're trying to do. But sometimes they're just, the goal of the campaigns or the groups are not around generating revenue. And it's just not, right? Or it's very tangentially related to revenue. It's like, we're just trying to get more customers to come to our web page. We're trying to do a Halo campaign just to get more awareness about what we're doing.
Exactly, right. And so it sounds like us too, right? It's in the advertising, it's always the customer oftentimes does have their metric they care about, and it doesn't always speak to exactly, not dollar signs, but eyeballs or what have you, that they believe is their, and everybody has their favorite metric, and none of them agree. And to some degree, it's up to our customers to decide that. So it understood.
Yeah, I mean, I'm a very process-focused guy. That's where I came up through, is doing like, analytics on process and statistical things on process. So I oftentimes frame those in those things. And I find that is often orthogonal to people that come from, different views. So I'm very an Anthema kind of view in the advertising space, because I view the world differently as this process to put these things through, and like measuring where things are in the pipeline of that and trying to evaluate there and look at different metrics, ultimately about revenue, but certain things about like, quality as well. What is this in quality of that? And
what is this process? Like, Chris, when you mean you're a process kind of focused person, like, do you have a list of, like a list of metrics that you're working down and trying to figure out a roadmap to go through? How do you iteratively kind of improve the models, and what's the process? Can you share that?
Yeah, so I think John touched on it, right? You're essentially given, speaking to your model question first, you're given 3 levers to pull, right? And John characterized, we can talk about them differently, but John characterized them in the data space, in the algorithm space, and more data, better features, and different algorithms, essentially, right? And those are the 3 levers you generally have to pull, and you can pull those. Generally, my view on most problems is, we're in a world of data. We're swimming in data now. Getting more data, more rows, more observations generally doesn't help a lot. In fact, most of the times I'm dumping data to build models these days, which is are just awash in data. So that's usually not the first lever I pull. To John's point, like changing out the algorithms can be a whole different build, a whole different assumptions. So that one I put on the shelf too. Usually what I do to improve my models is attack the feature space. Are there better features? Can we extend the number of columns in our data set to feed into our algorithms that they can learn on? And that's usually the first place that I attack.
So it's less rows, more columns.
Yeah,
like
less rows.
Sending columns, yes.
Yeah, I'm not taking out rows, right? I have an idea of what the minimum number is, or I do some experiments ahead of time, figuring out like adding, doubling the amount of rows isn't going to appreciably change the model. So I like to keep things small to iterate fast, especially in the early stages. And so mostly it's about like figuring out what are the set of features. And I think we're in a transformative era in machine learning in one respect to features, because people are starting to view features not as static data in columns, but are parameterized pieces of code that you incorporate into your models and optimize over, right? And that
Right.
wasn't true as recently as 5 years ago. That really wasn't the paradigm. We would get this static set, maybe a different group would generate the features for us and would have that. And it's now shifting away from that concept to no, here is something like a look back window, how far I look back. But one of the parameters that we have to optimize that model over is, what's the size of that window? Is it the same size for everyone, or are there subsegments that, have different look backs? Is it duration, or is it a number of events that we look back?
Right.
And so we're starting, at least at ADARA, we're starting to conceptualize these things as, hey, here is another set of parameters that we're optimizing over, not just the coefficients that align themselves with the columns, but what are the actual parameters that define the columns themselves, right? And so the feature space is the most interesting one to attack. I think it's the one most machine learning people like to attack most. It's the one where people feel empowered by their knowledge of the data to actually bring something to the table. But the flip side of it, as a manager, put on my manager hat, it's often the most expensive thing to work on, right? So, but that's the place I like to attack first.
Right, and actually that's very interesting because it's true. I kind of when I interview people or I talk about this, I kind of rail on this notion that twofold: just more data doesn't make things better. And look, for example, in neural networks, just deeper networks is not where you want to be. I like parsimony. I like simplicity. I like that. Occam's razor first and foremost. But I agree with you. And the fact is, technically speaking, I hate this notion of the Kaggleization of here's a stationary set, go do everything else but do that, and then go and argue about the fourth decimal place on a metric somebody else chose. Oh, I did 0.008 on RMS. Who cares? It doesn't make sense. It drives me crazy. And so that speaks to what you're saying for sure. And that is, it's not just a grab bag of throw it all in and see what stacks up. Let's have some intelligence. But let's also not focus on a stationary single set, because the world is streaming and it's getting bigger. It means we sip the fire hose and we have to make sure that model looks good. This sip, and this sip. So it speaks to the volumes we see in both our industries, I'm sure speak to that exactly.
Yeah, and to your point, like the best model you can have is the one that's in production, right? That parsimony is really important. And I've seen many projects fail because they're trying to be too complex. And really, like our practice, one of our practices is when we go into building a model that's in a production system, which most are now, they're not standalone, is the first thing we do is we put something that's going to generate a random number, like just a random number or a random category, just so we can get the piping end to end working. So we know that we can build it, right? And because we have to contract with the engineering groups and have hands-off, and the product groups and the design groups. So the first thing we do now is okay, put in the random number generator, get our model, understand how they're going to call our model, and get our model to score something. Right. And then that gives us enough defensive space that we can go back in and work on features, determine what we can get in real time versus offline and develop around.
How reliable is it delivered?
Yeah. I mean, and that was something, that was something that.
Sorry. Go ahead, Chris. Go ahead.
That's something like figuring that out was like a big win in my career. Just stand it up end to end, put out the random number generator, and then just worry about incrementally getting better. Because then everyone else could do their work, and I have a defensible space for which I can iterate over my model. And at some point, you got to say, we're ready for production or not.
That was literally, you guys have done a great job. I don't even have to ask a bunch of questions. You guys have asked each other a ton of questions. But that was going to be my next question, which is, that struggle of going from research to production. Like you said, the best model is the one that's actually in production. And so why do you think it's difficult? I mean, do you think it's the handoff to Eng? Do you think it's, there's probably a lot of different components of it. I mean, I'm seeing that too, getting features in real time versus in batch. There's a lot of assumptions you make in the offline world that might not hold up in the online world.
Which of course you should be considering before you start making models offline with those features.
Yeah. And what do you think would, what, I guess, do you think it's because there's a handoff from DS to Eng? I mean, do you think that there's a world of companies that are moving towards full stack data scientists, and they're, data scientists who actually
that's what ML engineers are.
That is what ML engineers are. Yes. And then
definition.
And I was going to say, in other companies, there's ML engineers who build the model and then deploy it into production, and there's a whole host of different roles that are coming up to really move that model from research to production. Any challenges that you think you faced? How would you address all the challenges that come from that?
Which Chris or I?
Either one of you. Chris, you can go if you want.
I'll start.
Okay.
So I think the handoff is real, right?
Yeah.
So one of the things we develop our models in an agile Scrum methodology, and one of the things, and the team points it out, and the team themselves comes together and points it out as part of that process. And so one of the things that is quite evident is that whenever there's a handoff, the points and the amount of effort goes up, right? Because you are not guaranteed to have those resources. And whenever we know there's going to be a handoff, we push the deadlines out, right? That is a very real consideration. I think the other thing is similarly related is there's a knowledge gap, right? Like the machine learning engineers, the data scientists, they don't necessarily know how all the piping and the infrastructure works in the live systems, right? And I think they have a conception about it, but maybe they don't know. Maybe they need to go out and get that information, some information. Maybe they have to figure out, do some investigative research into what's available in real time, what the sources of the data are, where they plug in, and have those conversations. And you hope you have those conversations ahead of time, but sometimes you're kind of 11th hour and you hear we can't get that. And so you're like, oh crap, we got to go rebuild that, right? And it happens. And I think to John's thing was saying earlier is, really getting a handle on what data are you going to get in real time versus offline. And because we're back in the day you could do everything offline, but more and more as everything's been moving increasingly to real time, we're in this hybrid model right now. And so you have to know that the assumptions around how delayed some of this data is going to be, and is that good enough? So once you move off of the bench and into production, right? There's a dozen or more considerations that you're suddenly faced with, and you kind of have to check those boxes, and you have to do the testing. And if you have a test platform, you have to test it, and if you have the ability to roll out in chunks rather than all at once, you have to be able to do that, right? And so there's a whole lot of engineering and other considerations that go into that just makes it more difficult than building just a model in Python or R.
Yeah, good. Yeah, that's the fun part, and you're right.
If only.
Yeah, exactly right. But someday our goal is here's a model and it throws off, and there's a server that just puts it in production, and that doesn't happen, right? That's a very, very difficult task. And I agreed. It's really
get on that. We want that.
Yeah, exactly.
This is feedback from your customers. Get on that.
Oh God, yes, the turnaround from customers, Steve. But my background originally was electrical engineer, so same thing. It's all about the constraint spaces, and so it's somewhat speaking. You do like to have that prior knowledge if you can, whether things are available at what juncture in the process, whether offline or online, and what your model is going to actually be get to do. Because we do have a trade-off in our system of some models can be done prior and then the outcomes are saved, or you need to react in real time, obviously. But it's really, end of day, it boils down to this constraint space and a trade-off where, okay, I've got the great model offline, and what's that translation to, as you say, places where I'm probably unfamiliar with the details because I'm not, DevOps. I don't know how the hell, Redshift really works in the hood, or do I know how Kafka is going to be populated? I have no idea, right? So I need to figure out how can I put this together.
And I don't want to know.
And that's exactly right. That's as they say in the Hitchhiker's Guide, that's somebody else's problem.
Yeah. Don't tell me. Don't tell me. I don't want to know.
Yeah, because I remember I had the
if I learn, you're going to ask me to do more.
Well, that's a sad scenario. And of course, we talk about full stack, but I don't think that anybody can truly comprehend all the nuances of machine learning and then still know the full stack to deploy it. It's a rare individual.
Totally.
It's a specialization, and so it's a handoff. It's a constraint space. It's a trade-off. And right, it's and then put in perspective. If you recall, the most famous challenge, of course, the original Netflix challenge Well,
Yeah.
offline, great. Well, they deployed, the people who won had blended 20 models together. And I knew the guy who was responsible at Netflix, Andrew Weiss, his name was, who was supposed to be tasked with just evaluating and seeing if it was even tenable. And they looked at it for 3 days and said, no way in hell is this ever going to be able to be deployed with the complexity inherent. So you do have to put those constraints on and limit yourself up front relative to what you're expecting to do offline. You can't just say the best model bar none. It has to be the best model with constraints from the get-go. Otherwise, you're going to lead yourself down a path of backing away from what you really could do, the greatest in the world, to reality, which the reality is what we field in production, not the dreams you have of the best to the 10th decimal place model.
Yep.
It's constraint space. It's traversing and knowing all those nuances. Do I want to do it where I could, or do I want an expert to do it? I want an expert to do it.
One last question for y'all before before we wrap up here is, how important is it to think about observability up front? I mean, do you we talked a lot about getting that model into production, knowing all of the challenges that exist in production, but do you have today tools to do the model validation? Do you have tools to actually observe it in production? I mean, how difficult is getting all these insights about the models that you're ultimately going to use to improve the model in production?
Yeah, and make sure things don't go straight to hell, right?
Yeah.
So since this is something you and I have talked about for the last like 2.5 years, if you don't mind, I can go first, because this is near and dear to my heart, and Aparna had seen in person the trials and tribulations we had when a system doesn't actually have this observability to fulfill the needs of this, even considering data integrity from the simplest position. So I'd say it's, on the one hand, super important that you're able to know the state of the variables you expect to be in there, because if nothing else, if you can't expect the same kind of, at least distribution-wise or a range of categoricals, what have you, or even a live feed on a feature that could go dead, right? The 3 major problems we typically have. If you can't control that and see, then you're not going to know when your model goes to hell. You're not going to observe that in an instant that it's going. I liken it to, say, detecting disease. If you can't detect, say, eye disease today, and you wait a week, you could be blind by then. And in fact, we need to determine it now, take 0 losses, cut that off, and be able to understand we're on a trajectory towards bad stuff, not we're in health. We've lost all our inventory. We're there, we're on their way there now. So I would say it's utterly important, difficult, and most systems, as I'll speak to our system, structured today that are big and complex, don't actually have that. So that's true at TubeMogul and true at Tubi. We didn't have that as much as we would have liked. And that's an after the fact, look at it after, oh, here's the postmortem, here's what happened. No. It should be dynamic. And I do, like I say, having tooled with your system a bit, like and understand that if you can easily instrument stuff with that, that's low cost and non-interfering, awesome. Yep. Without having to structure my entire system around that, and it could be off to the side and tapped off. I think it's unbelievably valuable and could probably save lots of companies lots of heartache and debugging and lots of money by being able to see that headed off at the pass. That's my belief.
I think your last one is really important, the money, right? Like if in a good observable system, right, I don't have to have my data scientists, machine learning engineers tapping into it to figure out what the model is doing, right? I can offload that to some operations person or some campaign manager or someone who's working with one of our clients.
Exactly.
And say, like, it's your job to like make sure that this is, working for your client, and this is the view that you need to look at, and you need to come to us, if you're seeing some anomalous things. Exactly. And otherwise, I'm spending a resource that's, I'm spending $200,000 a year on to babysit something, and that's not what first of all, that's not what they want to do, right? And that's not, their head is not going to be in that game. They do, asking like a rank and file, data scientists to do that. They don't generally do very good jobs, to be perfectly honest.
Right. No, well, why would you have vigilance on a simple task? It's not so fun. Therefore, I'm not going to pay attention half the time. Yeah.
Right.
I always say it's the most expensive type of babysitter.
Right.
Right. Well, you know what I like
data scientists right now are the most expensive type of anything.
Yeah, that's true. That's true. Just that title. But I liken it to, the age-old movie scene where the security guards looking at that array of, 8x8 array of monitors, And by golly, he didn't catch that we see the robber doing whatever there. That's what this is all about. And in fact, even at NASA, even at SpaceX, they still even do, say, the anomaly detection on their telemetry on a freaking one-off basis with red lines. It's a complex system with interactions that we should be tracking and looking at. So long story short is I believe your endeavor at Arize is noble and it's helpful. And I think it'll be super useful to everybody as you go along, and it's easier and better and cheaper to insert that kind of stuff and have that seen, because you're going to save a lot of people a lot of money and make heroes out of people who would otherwise be definitely in big ass trouble, like I've seen people be.
You are definitely saving lives and stopping global warming at the same time. Like, you guys are amazing.
Seriously, John, Chris,
Yes,
this has been so much fun. I don't want to keep you guys much longer than you have to be, but thank you so much for joining us and being on this panel. And for everyone who's watching, thanks for joining us.
Well, it was fun. Thanks.